Hello everyone, Dr. Mungli here. In this video, I'll be explaining you on vitamin D, especially activation of vitamin D, regulation of vitamin D levels and major functions of vitamin D. So vitamin D, we get it from plant source and animal source. So from animal source, basically we get from the skin, we have 7-dehydrocholesterol. 7-dehydrocholesterol. So under the influence of UV light, especially UVB light, it will be converted into cholecalciferol. And that is referred as vitamin D3. This is provitamin D3. This is an inactive form of vitamin, that is cholecalciferol. From plant source, we have ergosterol, and this ergosterol is converted to ergocalciferol. And ergocalciferol, we call it as provitamin D2. So this is also again with the UVB light. Now whether it is 7-dehydrocholesterol, which is converted to cholecalciferol, ergosterol converted to ergocalciferol, that is vitamin D2. So ultraviolet B light, especially in humans, what happens is whenever we expose to sunlight, especially ultraviolet B light, so the ultraviolet B light, it is going to change some of the rings present in 7-dehydrocholesterol, that is especially B ring, and converts that into cholecalciferol. It all depends on how long we expose ourselves to the sunlight, especially the intensity of ultraviolet B light is important here. And that also depends on the skin color or the pigment, that is melanin, because melanin is going to prevent ultraviolet B light penetration into the skin, so that decreases conversion of 7-dehydrocholesterol into cholecalciferol. That is why people who are darker in color, because of the high levels of melanin, so they will be having less conversion of 7-dehydrocholesterol into cholecalciferol. And also use of sunscreens will decrease conversion of 7-dehydrocholesterol into cholecalciferol. And also the intensity of sunlight that someone is exposed, so that can also decrease 7-dehydrocholesterol into cholecalciferol, especially people who are living away from the equator where sunlight exposure is minimal throughout the year, so that decreases cholecalciferol formation. Now overall, whether it is cholecalciferol, that is provitamin D3, or ergocalciferol, that is provitamin D2, so both of them, so they need to be activated first. So the activation of these two molecules will happen in liver. So the liver, it has 25 hydroxylase enzyme, and this 25 hydroxylase enzyme, it is a mixed function cytochrome P450 mixed function oxidase, especially it is cytochrome P450 2R1. This is the subtype of cytochrome P450. So this is the enzyme which is causing hydroxylation at the 25th carbon of vitamin D2 and vitamin D3, and it is going to provide 25 hydroxy vitamin D. I'll just write it as D there. 25 hydroxy vitamin D3 or 25 hydroxy vitamin D2, depending on whether we get it from animal source or plant source. This is what happens in the liver, 25 hydroxylation. Once this 25 hydroxy vitamin D3 and vitamin D2 is released, so they will bind with vitamin B binding protein. So these two will be binding to vitamin D binding protein, that is, I'll write it as VBP, vitamin D binding protein. Now vitamin D binding protein. Let me just expand this. Vitamin D binding protein. So this vitamin D binding protein, it has got higher affinity for 25 hydroxy vitamin D3. 25 hydroxy vitamin D3 is predominantly binding because it has got higher affinity for vitamin D binding protein compared to 25 hydroxy vitamin D2 coming from plant source. That is why majority of time what happens, this 25 hydroxy vitamin D2, it will be rapidly degraded. That is why availability of or the conversion of 25 hydroxy vitamin D2 into active form of vitamin D, that is 125 dihydroxy vitamin D, it will be very less coming from ergo calciferol. That's because 25 hydroxy vitamin D2, it has got lesser affinity for vitamin D binding protein. Because of this, it is rapidly degraded. Unless you are supplementing yourself with plant derived ergocalciferol 25 hydroxy vitamin D2, so contribution of this molecule to active vitamin is very less. Now one that is coming from animal source, that is vitamin D3, provitamin D3, making 25 hydroxy vitamin D3, so that will be majority of time it will be carried to the liver, to the kidney. Now it will go to the kidney, and in the kidney we have 1-alpha hydroxylase enzyme, 1-alpha hydroxylase enzyme, and this 1-alpha hydroxylase, it is also cytochrome P450, but the subtype 27B1, cytochrome P450 27B1, this is the subtype of cytochrome P450 mixed function oxidase, that is 1-alpha hydroxylase enzyme located in the renal tubular cells. So what this enzyme does, it is going to hydroxylate 25 hydroxy cholecalciferol into 125 dihydroxy, I'll write it as OH2 dihydroxy vitamin D3, and this is an active form of vitamin D. So basically this 125 dihydroxy cholecalciferol, it has got a hormonal action. It acts similar to that of steroid hormones. It has a steroid hormone action. So it means it's going to go and bind with cytoplasmic receptor, get into the nucleus, and it's going to activate a transcription process. So 125 dihydroxy cholecalciferol, and that is made from 1-alpha hydroxylase in the kidney. So overall, provitamin D3 or provitamin D2, it needs two hydroxylation process. One is in the liver by 25 hydroxylase enzyme, another is in the kidney by 1-alpha hydroxylase enzyme. Out of vitamin D3 and D2, D3 it is going to predominantly go into formation of 125 dihydroxy cholecalciferol because it has got higher affinity for vitamin D binding protein. Note that this vitamin D binding protein, it is synthesized in the liver. Vitamin D binding protein is synthesized in the liver. So any liver disorders, liver diseases, it can lead to decreased synthesis of one vitamin D binding protein, and also it will decrease hydroxylation process. That's how liver diseases can give rise to vitamin D deficiency. In the same way, you can apply this concept for kidney disorder. Say if the person has got kidney failure, end stage renal disorder, during that time also the cytochrome P227B1, which has 1-alpha hydroxylase activity, that can decrease. That is why in renal failure, so there can be decrease in vitamin D levels. So that's another cause for vitamin D deficiency. Now let's move on to see how this vitamin D is regulated. Now regulation of vitamin D, that is an active form of vitamin D. Say we have 125 dihydroxy vitamin D3, which is also called as calcitriol. Calcitriol this is a calcitriol. It has got 3 hydroxyl group, but we have what is shown here is 125, but it will be having 3 hydroxyl group. Calcitriol, which is a biologically active form of vitamin D. Now let's see what all the factors that control this vitamin D, active form of vitamin D. So vitamin D levels will be controlled by parathyroid hormones. Parathyroid hormone, so whenever there is increase in parathyroid hormone, so parathyroid hormone, it is going to stimulate 1-alpha hydroxylase enzyme. 1-alpha hydroxylase enzyme in the kidney, and this 1-alpha hydroxylase enzyme is going to make 125 dihydroxycholecalciferol. Now, for whatever the reason, whenever parathyroid hormone is elevated, so generally what happens, so the parathyroid hormone will be elevated whenever there is hypocalcemia, decrease in calcium levels. So it will be sensed by parathyroid glands, and parathyroid glands will release parathyroid hormone, and this parathyroid hormone is going to activate or increase the expression of 1-alpha hydroxylase enzyme in the kidney. Thereby 1-alpha hydroxylase is going to increase 125 dihydroxycholecalciferol. Okay, so this is how parathyroid hormone levels, parathyroid hormone is going to increase 125 dihydroxycholecalciferol. Now whenever there is sufficient levels of 125 dihydroxycholecalciferol is available, so that 125 dihydroxycholecalciferol will decrease parathyroid hormone synthesis from parathyroid glands, because 125 dihydroxycholecalciferol, it has got proliferative effect on parathyroid glands. Thereby it's going to decrease formation of parathyroid hormone. Thereby its effect on 1-alpha hydroxylase is decreased. Thereby 125 dihydroxycholecalciferol synthesis decreases. This is what is the effect of parathyroid hormone on 125 or 125 on parathyroid hormone. Now let's see what is the other regulatory points related with 125 dihydroxycholecalciferol. Now 125 dihydroxycholecalciferol is regulated by another enzyme called 24 hydroxylase enzyme. 24 hydroxylase enzyme is expressed in most of the tissues, especially in the liver. So what this 24 hydroxylase does, it is going to convert 125 dihydroxycholecalciferol into 124-25 trihydroxy vitamin D3, so trihydroxycholecalciferol. 124-25 trihydroxycholecalciferol, which we call it as calcitroic acid. And this calcitroic acid, most of the time it's an excretory product. It is a biologically inactive molecule, so it will be excreted in bile, so that gets into feces. So this is, although vitamin D is a fat soluble vitamin, but still our body is able to excrete it in the form of calcitroic acid. That's how whenever there is excess of 125 dihydroxycholecalciferol, during that time, so there will be activation of 24 hydroxylase enzyme, and that is going to convert 125 into 124-25 trihydroxycholecalciferol, that is calcitroic acid, which is excreted in the bile getting into feces. That's the regulation of 125 dihydroxycholecalciferol. Now another regulation of 125 dihydroxycholecalciferol is 125 dihydroxycholecalciferol itself. Whenever there is excess levels of 125 dihydroxycholecalciferol, so this 125 dihydroxycholecalciferol will have an feedback negative effect on 1-alpha hydroxylase enzyme. So thereby 1-alpha hydroxylase enzyme activity decreases, and 125 dihydroxycholecalciferol activity, means the concentration goes down. Now what are the other factors that can control 125 dihydroxycholecalciferol? And that is fibroblast growth factor 23. FGF 23, fibroblast growth factor 23. this fibroblast growth factor 23 is going to decrease the formation of 125 dihydroxycholecalciferol. So it has got a negative effect on 125 dihydroxycholecalciferol. Now hypercalcemia, excess calcium level, hypercalcemia. So whenever there is increase in calcium level, so this increase in calcium level will have a negative effect on parathyroid glands and decreases parathyroid hormone. Thereby parathyroid hormone effect on 1-alpha hydroxylase is less. That's how hypercalcemia can decrease 125 dihydroxycholecalciferol synthesis. Then hyperphosphatemia. Hyperphosphatemia also decreases 125 dihydroxycholecalciferol, but the mechanism is hyperphosphatemia leads to increase in the formation of, it has got a positive effect on fibroblast growth factor 23, and this fibroblast growth factor 23 will have a negative effect on 125 dihydroxycholecalciferol formation. So that's how hyperphosphatemia is going to decrease 125 dihydroxycholecalciferol. So these are some of the regulatory points. Let me quickly revise all this. So 125 dihydroxycholecalciferol levels will be maintained or regulated by a variety of factors. In that, one is the parathyroid hormone. Now the parathyroid hormone levels will be increased whenever there is a decrease in the calcium level, and parathyroid hormone it going to induce 1-alpha hydroxylase in the kidney. Thereby 1-alpha hydroxylase makes 125 dihydroxycholecalciferol. Now whenever there is a sufficient 125 dihydroxycholecalciferol, so that is going to have a negative effect on parathyroid glands, that is anti-proliferatory effect. So it's going to decrease parathyroid hormone levels, thereby its own synthesis is decreased. Now when there is excess levels of 125 cholecalciferol, it will have a feedback negative effect on 1-alpha hydroxylase. And also when there is excess levels of 125 cholecalciferol, so it will be inducing or it is activating 24-hydroxylase enzyme. Thereby it is going to be converting into 1,24,25 trihydroxycholecalciferol, which we call it as calcitroic acid, which is excreted in the bile and appears in feces. Now excess levels of fibroblast growth factor 23 is having a negative effect on 125 dihydroxycholecalciferol. If the person has hypercalcemia, so it is going to decrease parathyroid hormone, thereby it has got its effect on 1-alpha hydroxylase is not there, so that decreases 125 dihydroxycholecalciferol. Hyperphosphatemia will have a positive effect on fibroblast growth factor 23, thereby fibroblast growth factor 23 will have a negative effect on 125 dihydroxycholecalciferol. So this is all about regulation of 125 dihydroxycholecalciferol. Now let's move on to see some of the major functions of 125 dihydroxycholecalciferol. Now 125 dihydroxycholecalciferol will have an effect on intestine. It will have an effect on bone, and it will have an effect on kidney. These are the three major organs where 125 dihydroxycholecalciferol will have an effect. Now in the intestine, this 125 dihydroxycholecalciferol, it's going to go and bind with vitamin D receptors in the intestinal, in the enterocytes, and note that vitamin D receptors now it has been found, they have been found in variety of our tissues. There is a recent research, like in recent years thousands of papers have been published on 125 dihydroxycholecalciferol action and the presence of vitamin D receptor in variety of tissues. That is why 125 dihydroxycholecalciferol is a dynamic molecule, so it is not only acting on the intestine, bone and kidney and maintaining the calcium and phosphate, it has got so many effects on our metabolism. So there is so much to say about it, so I really don't have time here, so to make the video within 15 to 20 minutes, I'll be restricting myself to major functions of vitamin D, that is intestine, bone and kidney, to maintain calcium and phosphate level. So how it's going to increase calcium and phosphate in the intestine? So it's going to bind with vitamin D receptor, which is a cytoplasmic receptor, and this is associated with RXR receptor. This is a nuclear superfamily of receptors. So this vitamin D RXR dimerized receptors, what it does, it is going to go and interact with vitamin D response elements. And this vitamin D response element leads to transcription process, mRNA, and there will be increase in the expression of calcium channel on the intestinal epithelial brush border surface. And also it is going to increase the expression of calcium binding protein, that is CalBP, calcium binding protein, which is also called as calbindin 9K. Now, because of this increased expression of calcium channel and calcium binding protein in the intestinal epithelial cells, so there will be rapid absorption of calcium and phosphate into the blood. So, increase in calcium and phosphate, PO4 minus, 2 plus, and PO4 minus into the blood. Calcium and phosphate in the blood is maintained. That's the effect of 125 on intestine. Now the effect of 125 on the bone. So in the bone, 125, it is going to go and bind with vitamin D receptor again. So it is VDR RXR receptor, and thereby it is going to increase, it's going to interact with VDRE, vitamin D response element. Especially this happens on the osteoblastic cells, VDR, RXR, VDRE, and then there will be expression of rank ligand. And this rank ligand, it's going to interact with the rank receptors on the pre-osteoclast. So there is an interaction between rank and rank receptor here. So it means when vitamin D binds to vitamin D receptor RXR, vitamin D response elements activated, and it's going to, the osteoblasts are going to express rank ligands, and these rank ligands are going to interact with the rank receptors on pre-osteoclast. That's when pre-osteoclasts are activated into mature osteoclast. And these mature osteoclasts, they are going to do the demineralization of the bones and lead to release of calcium and phosphate into the blood. That's how 125 dihydroxycholecalciferol releases calcium and phosphate into the blood, thereby maintain the calcium phosphate level. Now the 125 dihydroxycholecalciferol will also go to the kidney, and it increases reabsorption of calcium and phosphate from the renal tubular cells. That is a reabsorption of calcium and phosphate from renal tubular cells, and maintain calcium phosphate levels in the blood. So this is about the function of 125 dihydroxycholecalciferol. Apart from these three major organs, it is going to act on a variety of tissues in our body. So vitamin D, it is having a role in insulin sensitivity. Thereby it prevents diabetes mellitus. Vitamin D has got a role in anti-proliferation function, anti-tumor activity. It decreases angiogenesis, thereby decreases tumor formation. And vitamin D has got a role in variety of metabolic pathways. And vitamin D has been denoted in immunological mechanism, immune function, immune cell differentiation. So it means vitamin D is a dynamic molecule. It has got so many other functions of vitamin D have been detected in a recent research, but the classic function is it is going to increase calcium and phosphate. It is going to maintain calcium and phosphate levels in our body. So this is all about vitamin D. There is so much about vitamin D, but there is so less time that is available here. So just to keep the video short, so I hope I have explained vitamin D, and you got to the best of my ability, and I hope this video has helped you to understand some of the points about vitamin D. Thanks for watching. See you again in my next video. Till then, take care.